We're factoring completely today. Match the expression with its factored form. Justify your answer with some work. Okay. All right. Now, if we were factoring number one here, 4x squared, I see as a perfect square. I see 81 as a perfect square. So it might be one of those perfect square trinomials. The square root of 4x squared would be 2x. The square root of 81 would be 9. The symbol between them would have to be the first symbol. But to double check, remember you have to multiply them together and multiply by 2 to get that middle term. So 2x times negative 9 is negative 18x times 2 is negative 36. So that one worked out. That was D. 2. All right. The next one, this would be a factoring by grouping kind of problem. So we would split it down the middle. Greatest common factor on the left would be 3x squared, which would leave us with x minus 2. And then over here, we can, greatest common factor is a 1, which leaves us with x minus 2. So we have 3x squared plus 1 on the outside. And then inside, we have the x minus 2. Let's see if that's one of our options. Oh, snap. That's big. 27x cubed plus 216. Well, I see a 27 in front. So I'm going to guess that 27 goes into 216 as well. Let me check that. I don't know. Probably 8. 216 divided by 27. 216 divided by 27. 8. All right, so if we factor out the 27, we're left with x cubed plus 8. Now, those are both cubes, so I know this could be the sum of cubes. I mean, we already know the answer is E because we have a 27 as the greatest common factor. But remember, for the cubes, you cube root each one, so that would be x plus 2. Then you square that first term, so x squared. You change the sign, so it would be minus. Multiply them together, 2x plus, square the last term, 4. So that would give us E on that one. Here's B, here's D, 2. So we have A and C. It's pretty easy to see which one is which, but let's pretend like we just had to factor this and it wasn't a multiple choice question. The only difference here is like you'll see this exponent is 6. Usually it was like 2 and this was 1. So it's not bad. It's just the same thing except we'll cut this exponent in half so it'll be x to the third in both parentheses. So now let's just pretend like it's x squared plus 3x plus 2 with factors of 2 add up to 3, be 2 and 1. So x cubed plus 2, x cubed plus 1. Hey, these are both perfect cubes. Cube root of x cubed is x. Cube root of 1 is 1. So we'll keep the x cubed plus 2, and then we'll have our sum of cubes. Cube root of x plus 1, x squared, multiply them together, 1x, and then square that last term plus 1. So is that an option there? Yep. Oh, minus x. I forgot to switch the sign. Oh, Mr. Plant, come on, dude. Come on. Pay attention, Mr. Plant, please. Please pay attention. That's option A. Which leaves us with option C for number 5, which makes sense because that is the difference of squares. So you square root each one, put 1 with a plus, and 1 with a minus. All right, so today we're just going to practice that factoring completely. So check if you have a greatest common factor. Check if you have any perfect squares. You might have the difference of squares, or check if there's the cubes, right? And oftentimes you're going to want to check for the difference of squares near the end. So x cubed minus 8, those are both perfect cubes. So if we cube root them both, it'd be x and 2. So our first set of parentheses will be x minus 2. Second set is where there's 3 terms. Square the first term, change the sign, multiply them together, 2x, whoops. Put a plus and square that last term, 4. And you can't there are no factors of 4 that add up to 2, so you would be done at this point. But you do want to double check your stuff. Make sure you can't factor anything else. Greatest common factor here is a 2, which would leave us with x cubed plus 1. Can you cube root both of those? You bet. Cube root of x cubed is x, cube root of 1 is 1. So we'd have x plus 1, square the first term, x squared, change the sign, multiply them together, 1x, and then square that last term. No factors of 1 or 1 apart. So that would be our final answer there. Sweet, we're cruising. Cruising for present, dude. Oh, there's 4 terms. Well, first I should probably look for a common factor, which there's not. So that's where, what color did I use up there? We gotta keep it cute and colorful. So we're gonna use green. We're gonna split it right down the middle, 2 terms on each side, factor each half. So the greatest common factor on the left would be 4x squared, which leaves us with 2x plus 5. Greatest common factor between 10 and 25 would be 5, which leaves us with 2x plus 5. So the stuff on the outside, 4x squared plus 5 would go in one set of parentheses. The other set is the 2x plus 5 that they have in common. Now double check, look at the one with the square and see if there's a difference of squares. And there's not, because A, it's addition, and B, 5 is not a perfect square. But if that was like 4x squared minus 9, then you would keep going. And you would do 2x plus 3, 2x minus 3, and then the 2x plus 5. But that was all we could do for that one. That was it. V to the 4th minus 81. Now, those are perfect squares. When you square root, and it's not just x to the 2nd power, you just divide the exponent by 2. So the square root of v to the 4th would be v squared. The square root of 81 would be 9, so it would be v squared plus 9 times v squared minus 9. And check if there's a difference of squares left. Now this is the sum, so we can't do anything there. But this is difference of squares, so we'll rewrite the v squared plus 9 because we can't factor that anymore. But v squared minus 9 would be v plus 3 and v minus 3. Now eventually we're going to be solving these with equations and we're going to say find all the zeros, just like we did when we first did factoring. So you would say like, oh, well, v could equal positive 3, v could equal negative 3, and then for this portion over here, you would solve the equation v squared plus 9 equals 0, subtract your 9, and you square root it, and the square root of negative 9 would be plus or minus 3i. So that's eventually where we're going. Then you can do that no problem because you are so smart. All right, let me move over here. Greatest common factor? No, just 1. They're both perfect cubes. Cube root of 1 is 1. Cube root of 8x cubed would be 2x. So cube root them both. 1 minus 2x. Square the first term. 1. Change the sign. Multiply them together. That would be 2x. Put plus. Square that last term. 4x squared. Now this isn't typically the order you would see it in. If this was written in standard form, it would be 4x squared plus 2x plus 1. So if you want, because that can't be factored anymore, so this is fine. Or if you want, you can rearrange them both in the standard form, which would make this negative 2x plus 1. And I've told you guys in the past, if your first term is negative, you should always factor that out. So both of these answers are delightful. So choose your own adventure on that. I don't even have a preference. Usually I would say like, well, this is what I'd like to see. Either way is fine, okay? But make sure you can't factor anymore before you circle up your answer, okay?